Hi there. Well, I think what we're going to do is we're going to try to look at section 7.5, and then we only have 7.6 and 7.7. Now, I'm going to email this to you, but we're going to go in a little different order than what's emailed. So when we're looking at this, we're going to be looking at complex fractions. Complex fractions are fractions within a fraction. So here, if you look at these two examples on this first page, even though we're not going to really start here, you've got these two fractions within one large fraction. And so it's almost like two little fractions within a larger fraction. And again, here you've got fractions within a fraction. And we're going to learn how to simplify those and how to get rid of those little fractions so that we only have one fraction, if any fraction at all. It may reduce down to an integer or just a simple monomial. But the two methods we're going to look at, methods 1 and 2, I want to start with method 2. Method 2 is used more often than the method 1. And method 1 can be easier, so we'll just go ahead and get this method 2 over. So if you look at your second page of the handout that I'm going to email you, and again, you don't have to run them off, you can just follow this. This new document canvas is pretty good. But in this method, okay, if you look here at this fraction, I have fractions within a larger fraction. And what we're going to do is we're going to multiply by the number 1. And that number 1 will be like an x over x, or an x squared over x squared, or an x plus 3 over x plus 3. So we're going to be multiplying this fraction by the number 1. And I have what's going off. All right, so sorry about that. So in this first one, if you look at these two little fractions, what you'd like to do is come up with the least common denominator for those little fractions. We have two little fractions, and we have an x as a denominator and an x squared. So the least common denominator between those two would be x squared, because they both have an x, and when you find the least common denominator, you use the largest one, so which would be x squared. So I'm going to multiply this fraction here by x squared over x squared. And remember, you can multiply anything by 1 and it doesn't change its value. So in other words, 6 times 1 is still 6, or x times 1 is still x. So in multiplying this first fraction, we're going to multiply by x squared over x squared. So we'll be multiplying by the number 1. Now, when you do this, when you multiply this first numerator by x squared, sweetheart, could you turn that down a little bit? I'm recording this lesson. Thank you. Thank you. Okay. All right. So in this case, you'll take x squared times 1, x squared times 2 over x squared times 1, x squared times 4 over x squared. So we'll be multiplying every term by the x squared. So here, I'll go ahead and I'll just write that out. 1 times x squared plus 2 over x times x squared. Okay. Then you'll take the 1 times x squared minus, and then our next term is 4 over x squared times x squared. So every term in that complex fraction will be multiplied by this least common denominator of the little fractions. Now, we're going to take each of these and we're going to reduce each of those right there separately. So the first one, again, this upper left, 1 times x squared, plus, you reduce the next one. Well, this will cancel because you subtract exponents when you're dividing. You can put this over 1 if that helps. And you end up with 2x when you multiply across. So when these bases are the same, you subtract exponents. 2 minus 1 is 1. Okay? So there's our numerator, x squared plus 2x. Let's go to the denominator. We take 1 times x squared. We have a subtraction. When I multiply this fraction by the least common denominator, you can put that over 1 there. Those cancel out, and you end up with 4. Now, all I've done is I've found an equivalent fraction. It has the same value as what we started with. It's just easier to work with and reduce. Now, we're to section 7.1. You factor if you can, and then you simplify if you can. Well, to factor the numerator, take out what's in common. Oops, so if you take out an x, you don't have x squared anymore, you just have an x. X times x gives you x squared plus 2, that looks like a minus there, we don't want that. 2 times x gives you 2x. So I'm just factoring the numerator, factor the denominator, a difference of 2 squares, minus 2 plus 2. And in this case, we can reduce. X over x minus 2. This fraction is equivalent to the one we started with. So if you were to put an x into this first one that we started with, let's say you could put in the number 2. And no, you couldn't, because then you'd end up with the 0 in the denominator. But you could put in a 4 for your x's, okay? And 4 for the x here, and you'll get the same value. So they have the same value, it's just that one is easier to look at and to graph, to find an asymptote at x equals 2, rather than this one up here, okay? It's more of an appearance idea. It's not a value idea. It's more of an appearance and which one's easier to work with. All right, let's try another one. Maybe without some algebra. Again, on this one right here, the calculator would reduce it for you. But we're going to go ahead and practice method 2. So we're going to identify, we're going to find the least common denominator, and then we're going to multiply every term by that least common denominator. Now, when you do that, each of these bottom denominators should cancel out if you've done it right. And then we'll simplify. So you need to ask yourself, what does 2, 4, and 6 and 8 all go into? Well, that would be the number 24. So 24 is going to be our least common denominator. So I'm going to multiply by 24. Okay, 24 over 24. Again, you can multiply anything by the number 1 and not change its value. So we're just trying to rearrange it so that it's easier to solve. So now that we found the least common denominator, we're going to multiply every term by that least common denominator. And in doing so, each of these little denominators should disappear. So we'll start out with 1/2 times 24, then 3/4 times 24, 5/6 times 24, 3/8 times 24. We'll start with 1/2. And I'm just going to go ahead and write this out. Then we're going to do plus 3/4 times 24. And then we'll have 5/6 times 24. Minus, because we have a subtraction there, so we have a subtraction here, 3/8 times 24. Now some of these, this part right here might get a little long, so I'm not sure if we'll be rewriting it every time, but we will until you kind of get the idea of it. Well, 1/2 of 24, 1/2 times 24 gives us 12. 2 and 24 give you 12. 3/4 of 24. So 4 goes into here once, 4 goes into here 6. I'm reducing before I multiply. You have to know. I just like to work with smaller numbers. So I'm reducing anything in the numerator with anything in the denominator. This goes back to section 7.2. If that's confusing, go back and look at that one. Once you've reduced, you can multiply straight across. So 3, you get 18, and we have a plus in between them. Okay. Now then we're going to look at the denominator, 5 6 times 24, and you can put that 24 over 1, and it reduces down. And 6 into 24, you end up with 4. 5 times 4 is 20. Minus, because I have a subtraction there, 3/8 times 24 over 1. Now 8 goes into there once, 8 goes into there 3. Once you've reduced your fraction, you multiply straight across. 9. Okay. Now we're going to finish. Now we'll simplify. So now that we have gotten rid of our complex fraction or little fractions within the larger overall fraction, we can simplify this. This would be 30 over 11. Yeah. And that cannot be reduced any further. So your answer is 30 over 11. So you're looking, let's kind of go through this one more time, and we'll practice another one before we look at method 2, in that you find the least common denominator from the little fractions. What would those go into, or what would all 4 of them go into, depending upon how many you have? In the first case, it was x squared, and in this case, it was 24. But either way, you multiply every term by that least common denominator, which we did in the second step here. And then once you've done that, you simplify it looking at section 7.2, and then you're done. Okay, I think here I have another one I'd like to look at. Now this one is not in your notes. If you need to, you can kind of copy that down. But I have 4 fractions within an overall larger fraction, this complex fraction. And so I'm going to look at my individual denominators and find the least common denominator of all 4 of those. My denominators are 4x, 3x, 2x, and just an x. Well, I'm going to look at the coefficients in front. So I've got 4, 3, 2, and 1. These are the coefficients in front. And all 3 of those would go into 12 evenly. Okay, that would be the 12. You can always break it down into primes, to find that if you need to. So all 4 of them go into 12, and they all have an x, and the highest power is x to the first. So I'm going to multiply by 12x over 12x. Okay, that would take care of everything. So we've got x to the first. Okay, that will be taken care of with the x that's with the 12. And the 4, 3, 2 would be taken care of with the 12. So I multiply by 12x over 12x. I'm multiplying by the number 1 if I were to reduce 12x over 12x. Now you take this 12x times every term. And I'm going to go ahead and write the 12x next to each of the terms. So I'm going to take 1 over 4x times 12x. That would be the first one. Then I'm going to have plus 2 over 3x times 12x all over 12x times 3 over 2x times 12x. I have a subtraction here, so I'll put my subtraction. 1 over x times 12x. All right. Now, once you've done that, you can just simplify each of these 4 multiplications. It's kind of like following PEMDAS. You multiply before you would add or subtract. So we'll go ahead and I'm going to go ahead and put my least common denominator over 1. Since I'm multiplying my least common denominator to a fraction, it's nice to make anything that's like a whole number over 1. Okay, the first one, we're going to multiply these 4 And then we'll see if we can simplify it. So let's start with this top left one here. When I take 1 over 4x times 12x over 1, the 4 and the 12 reduce 3 times. 4 goes into 12, 3. Oh, that was kind of delayed there. And then the x's cancel. So my first fraction is 3. Okay. Plus, in this case, 3 reduces with the 12, and the x will cancel. And again, your denominator should always disappear if you're multiplying by the correct least common denominator. So we end up with 3 plus 8. 2 times 4 is 8. Let's go to the next fraction that we're multiplying. We'll reduce, 2 goes into their 1s, 2 goes into their 6, and our x's just cancel. So in the denominator, we've got 3 times 6 is 18. Subtract. Our last fraction, the x's cancel. And it looks like I have, and we end up with a 1. Looks like I end up with 1 times 12. All right. So now then we'll just simplify. So we combine our like terms. So we end up with 11. And then here we end up with 6. So your answer is 11/6. Okay. So again, find your least common denominator, multiply every term by that least common denominator, and then reduce and simplify. All right, well, let's look at another one that might be a little bit more difficult. This would be on your 3rd page. Over here on the right, we have D is over here. We're going to ignore that for right now. We're going to look at this one. So it's the same idea. You've got 4 fractions within a fraction, 4 little fractions within a fraction. So you're going to find the least common denominator of all 4 of those fractions, and that's what you're going to multiply by. And if it might be a little bit longer, our least common denominator, because it's a little bit longer, I may not write it next to each of those because it might get pretty long, but it's the same steps. Okay, let's find the least common denominator. Well, in the section that we did on adding and subtracting, in order to find the least common denominator, they do need to be factored. So let's look at this. We've got 3, let's see, I'll just put it right here, over, this will be 2, take out a 2 minus 1. I can make that a little bit smaller fraction bar. So that denominator, I look for what's in common first, which we should always do when we're factoring, and it was a 2. So I took out a 2 here for that denominator, I factored it, and now you can check it. 2 times x is 2x, 2 times 1 is a minus 2. Let's go to the next fraction. Well, looking at that denominator, there's nothing to factor, so we can just copy it. Nothing to do on that next one. So there's our numerator in our complex fraction. Let's go to the denominator. Well, the denominator, the first fraction, cannot be factored either. That leaves us with x minus 1. Okay. Now the next fraction down here in the bottom right, that denominator can be factored. So we have our numerator, and this is a difference of 2 squares. So I'm just factoring my numerator so I know what the least common denominator is. All right, let's look at the least common denominator. Well, I've got a 2, so I know that my least common denominator needs to have a 2 in it from that first fraction. My least common denominator that I'll be multiplying by must also have a, I'm going to turn the light on, must also have an x minus 1. From, again, here, it's got to have that. Well, if you use an x minus 1, this one had an x minus 1, and this one had an x minus 1. And the highest power is to the first on all three of those, so we'll just do it to the first. X minus 1 takes care of quite a bit of it, of the least common denominator. And we have an x plus 1 as well. So there's my least common denominator. And again, you can kind of check, okay, the 2 is taken care of, the x minus 1, the x plus 1, the x minus 1, x minus 1, x plus 1. So everything is taken care of. Sorry, I hope the dogs don't bother you. They're barking. So that's what I'm going to multiply by. Well, rather than write this least common denominator next to each of these, it'll be kind of long. We're just going to go ahead and just say, okay, we're going to take this times this outside. Now, when I do take this first fraction times my least common denominator, the 2's cancel and the x minus 1's cancel. So all I'm left with is x plus 1 times 3. So that's what happens when you take your first fraction times this, the least common denominator. The x minus 1's cancel, and so do the 2's. Now I have a subtraction symbol right there. So now I'm going to take x plus 1 and reduce it with this x plus 1. So what I'm left with is 2 and x minus 1 times the 1. All right. So here we're left with 2 and x minus 1 times 1. So whatever you're left with, you multiply it to the 3, that numerator, or you multiply it to the 1. Okay, let's go to the denominator. This fraction times this. Well, the x minus 1's cancel, so they're gone. So you've got 2 and x plus 1 times the 1, whatever's left. So here, 2 and x plus 1, that's what's left, times the 1. So you end up with 2x plus 1, okay? Because that will cancel with that one. So you take what's left times the numerator, plus. Here, when I multiply this fraction times this, the x minus 1's cancel, the x plus 1's cancel. I'm left with just a 2 times the x. Okay. Now, do not, all right, you're okay, we've simplified it pretty well. We're to section 7.1 now. We're going to reduce this. And just be aware, try to resist the urge of canceling these two. Because remember that when you have a subtraction or addition, things go as a group or they don't go at all. So in other words, you can't separate these x plus 1's from anything else over here. So what you do need to do though is multiply these through and then simplify and do the same thing in the denominator. So we have 3x plus 3. And then we have a minus 2 times x and a minus 2 times a minus 1. So again, watch those subtraction symbols. Got to be careful of those. I'm going to move this up just a bit. So we're simplifying the numerator. We'll do the same thing in the denominator. Multiply the 2, 2x plus 2 plus this 2x. Okay, let's combine similar terms. So this gives us an x plus 5 all over 4x plus 2. Okay. Now you need to ask yourself if this can be simplified. You know, it doesn't hurt. You cannot factor the numerator. That's still an x plus 5. But you can you could factor the denominator by taking out a 2. That would leave you with 2x plus 1. Okay. And again, multiply through to make sure you come back to the original. But nothing cancels. So the x plus 5 cannot cancel with the 2x plus 1. So this would be your answer for that one right there. So, you know, I mean, there's some places to make a mistake here, you know, but it's the same steps every single time. And again, when you are multiplying the first fraction times this, the x minus 1's cancel and the 2's cancel. Whatever's left, that's what you multiplied the denominator by, okay? Whatever's left. So I don't think there's too many of those in your homework. All right, so now we've looked at that. Well, we could do one more because there's still E and F to do. And we may not do F here, but let's go ahead before we go on to the next method, and it won't take very long. It's a little bit simpler than this method. Let's go ahead and at least try E. Okay, F wouldn't be too bad. You're gonna have to factor a lot, but let's at least try E. So again, because it's similar to the last one we just did, we need to factor these a couple of numerators here in order to find the least common denominator. So I'm going to have a y squared for my first fraction. This will be y minus 3, y plus 3. Okay, that is the least common, or that's the factoring of that first fraction. And then what we're going to do is we're going to subtract. There's our first fraction. We have a subtraction symbol. Y over y plus 3. Okay, nothing to do on that second one. Okay, now let's go ahead and do the next one down below. And I'm losing my sunlight, so I may have to turn the light on overhead. But let's go ahead and look at this next fraction. We have y over factoring y minus 3, y plus 3, a difference of 2 squared. I hope you're getting pretty good at this factoring. I'm hoping it's not giving you too many fits. We have a minus. This one right here is 1, and we cannot factor that denominator. Okay, I can put parentheses around them. If you want to put parentheses around those denominators, that's fine, just so they look alike. Now, when you look for the least common denominator, you have these 4 fractions. You have a y minus 3, and the highest power on the y minus 3's is to the first. So we're going to multiply each of these fractions times y minus 3. And that'll take care of all the y minus 3's, and then I have a y plus 3. So I need to include a y plus 3 in my least common denominator. So we have y minus 3, y plus 3. So you factor and find the least common denominator. Make sure that everything in these denominators occurs in your least common denominator there. Well, we're going to go ahead and we're going to multiply our least common denominator out here to each of these fractions. The nice thing is, if you look at this first fraction, when you multiply those, the y minus 3 cancel and the y plus 3 cancels. So you're just left with a 1 times y squared. Okay, that was nice. I don't know if I needed to put it quite that far down. Let me move it up a little bit. So we end up with y squared. All right, now let's do the next fraction. Well, not everything, the y plus 3 cancels with this y plus 3. So we're left with y minus 3 times the numerator. So we have a minus. The minus comes from right there. We have the y times whatever is left, and it would just be y minus 3. Okay, again, you know, watch those subtraction symbols. Okay, it's still there. Over. We're going to have a y times, well, let's see, this cancels, and the y plus 3 cancels, so it's just y times 1. It's just a y. Minus, so we have a minus there. We have a 1. You can put the 1 there if you want to. We have y minus 3, and that just leaves us with y plus 3. So in this case, it really was important to put that -1 there because we're going to have to multiply it through and it'll change the sign. So you may want to always write down, like if it's a -1, go ahead and put that -1 down. Okay, let's simplify. We're going to multiply everything out. So we're going to use the distributive property. We've got y squared minus y times y is y squared. A minus y times a -3 is a +3. Watch that. That would be a place where you might make a mistake. Minus y times a -3 is a +3. Let's go to the denominator. We have a y. -1 times y is a -y. A -1 times a +3 is a -3. Okay. All right. So let's simplify. These y squared minus y squared is 0. So you end up with just 0 plus 3, which is 3. Y minus y is 0 minus 3. So you end up with 0 plus 3, 0 minus 3. And your answer is a -1. Okay. So we ended up with a -1 with all that. So just kind of take your time and write everything out, and you should be fine. Now, that's kind of the hard part of this section. The next part is a little bit easier. So this is going to be method 1. Now, method 1, you use this if your fraction looks different. So let's compare C and D. If you look at C, you have 4 fractions. Okay, so you have fractions within a fraction. But D, you actually have 1 fraction divided by, there's your division symbol, another fraction. There's only 1 fraction in the numerator and 1 fraction in the denominator. So you're taking this fraction divided by this fraction. So rather than write it with a bar, I'm going to use this symbol right here and use the division symbol. Okay, now, so I can rewrite this as x squared minus y squared. So you write the top fraction first, divided by, so instead of this fraction bar, I'm going to use this symbol, divided by, x minus y over y. Okay. This is section, what was it, 7.2? Yeah, 7.2. This is a copy dot flip. So when you only have 1 fraction over a fraction or anything, you don't even have to have a fraction down here. I would just use the copy dot flip, and we'll go through some examples here. So now, finishing this, it doesn't hurt to review our previous sections. Is it 7.3 maybe? Copy dot flip. All right. So again, now we are going to simplify before we multiply. It's just a lot easier if you do that. So we'll factor and then we'll simplify. This is the only one that can be factored. This is x minus y, x plus y. It's a difference of 2 squares. X minus y, x plus y. X times x is x squared. Negative y times a positive y is a negative y squared. And then you have no middle term. So let's cancel if we can, since we factored. This group can cancel with this one. This y, this is multiplication, so these can be separated from each other. This is going to cancel with that. So you end up with x plus y over x. Okay. and that cannot be simplified. So please resist the urge to cancel these x's. They cannot be canceled. You cannot separate plus and subtractions from each other. They go as a group or they don't go at all. They never go individually when they have a plus or a subtraction symbol between them. All right. Well, let's look at another one that might work with this. Well, let's go back to the first page because they say, wow, can you use this method on problems that we did earlier? So we're going to look at this one. This is back in the first page. Now, if you look at this one right here and you look at the second page, the first one that we actually did, let me find that one, maybe. Ah, here it is. Okay. Okay, these two, oops. So when we first started out, we multiplied everything by the least common denominator. And then I multiplied it all out individually. Now you don't have to write it out like this, you know, if you don't want to. You could just say, okay, x squared times 1. X squared times 1 is x squared down here. X squared times 2 over x, the x cancels, and it leaves you with one of the x's times 2, okay? But could we use method 1 instead of method 2? Could we use the copy dot flip on this one? Could we make it look like this other one that we did just now? Too many papers here. Could I make it look like this one so I could use this copy dot flip idea? Could I change it to look like this? And you can. I think sometimes it's a lot harder to do that, but I want to make sure that you can choose any method you want. So I want to make sure that you have access to this method 1 rather than the method 2 all the time. Because, you know, some people do choose to use a method 1 all the time. But let me tell you, some of the problems can get pretty tedious, and it's a lot easier to multiply everything by the least common denominator. But let's go ahead. Okay. Let's make it look so that we had just one little fraction over another fraction, so we can use the copy dot flip. So to do that, you're going to have to add these together, and then you're going to have to subtract these. So I need to take 1 plus 2 over x. What that means is I need a common denominator. So I'm going to take 1 plus 2 over x. Well, the common denominator, this is over 1. Our common denominator for this numerator here is x. So I'm going to change these. Well, yeah, I'll just to a denominator of x. Okay. And 1 goes into x. Okay, to go from here to here, you need to multiply by x. So I'm going to multiply that by x. So, which kind of makes sense. X over x is equal to 1, right? And then this one, to go from here to here, multiply by 1. 2 times 1 is 2. So this numerator is x plus 2 over x. Okay, you add the numerators and they have a common denominator. Okay, there's our, I got a common denominator and added them together. Now the next one, well, looking at this, I know that x over x was 1. So if I wanted a common denominator here, okay, in order to add those together, subtract them, the largest power is x squared, so I'm going to use it. To go from 1 to x squared, I multiply by x squared. Make sure you can, oh, you can't see that, sorry about that. So I'm going to use x squared as the denominator. To multiply, to go from this denominator to an x squared, I multiply by x squared, so you do the same thing with the numerator. To go from here to here, you multiply by 1, so 4 times 1 is 4. So this one is x squared minus 4 over x squared. So I got a common denominator. So now this bottom part then is this, x squared minus 4 over x squared. So I got a common denominator. And I added the numerators when I had a common denominator. So here it's in the form that we wanted, 1 fraction over 1 fraction. So I'm taking this numerator divided by this fraction here. So rather than write this bar, I'm going to use a division symbol. So I've got x plus 1. I'm going to write that down here. X plus 2 over x divided by x squared minus 4 over x squared. Okay. And now we do the copy dot flip. Then you can reduce, but you can't reduce until you do the copy dot flip. So x plus 2 over x times x squared. Can you guys see that? Yeah. X squared minus 4. Now, the only one that can be factored is this one, x minus 2, x plus 2. That one right there. So these cancel. And let's see, we've got x, here's you 1. That's gone. I did that right here. So you end up with 1 over x minus 2. Wait a minute, I'm missing an x. Did I? Oh, sorry. 1, it's x right there. Sorry about that. I knew I had to have an x in the numerator. It's x to the first. Okay. X over x minus 2. Okay, I forgot about that x right there. But when you multiply across, you get x to the first. Wow. So again, you can get a common denominator. Oops, let me move that down a bit. You can get a common denominator and make it so you have a single fraction over a single fraction. And then you can do your copy dot flip, all right, because you're taking this fraction divided by this fraction. Okay, so that is the method, that's method 1. And again, you could use either method on this one. You could get a common denominator and then do the copy, this divided by this right here. Now, when you divide by x over z, just remember that when you do the copy dot flip, it's 1 over xz, all right? Because this is xz over 1, right, as it's written right there. Or, which I think is a little bit easier, and unless I usually only use that that method 1 if you're given just 2 fractions. If that's the way the problem is presented, I would just do the copy dot flip. If it's presented where you have more than 1 fraction, like on B, I would just multiply everything by xy. Okay, those are your only 2 denominators, and I would just multiply everything by xy. And when you do that, here your first fraction, the y cancels with the y, and you're left with x times x squared, which is x cubed, minus, here the x cancels with the x, so you have a minus 5 times y. What's left? What's left times the numerator. I don't know, I just think that's a little easier than getting a common denominator. Now down here, when you take this xz times xy, you get x squared yz. Nothing cancels because you need to remember that this is xy over 1. Okay, and then you're done, because you can't factor anything and nothing cancels. because this has to go as a group or it doesn't go at all. So, but you know, you could have gotten a common denominator and then done the copy dot flip, and you'll end up with the same answer. Okay, all right. Well, that pretty much covers the two methods. And, you know, and I encourage you that if things look really difficult or you're struggling with these methods, please let me know. And I will help you. On the syllabus, I put the YouTube channel, and I also put my Zoom room and my phone numbers on there on the syllabus, and you guys can text me, which is really the best method because then I get it right away. And or you can email me, and I'd be happy to set up a Zoom. Just you can come into my Zoom meeting and we can work through some of this stuff. Okay, so I will be emailing you because I opened up a quiz, and we have 2 more sections. So all right, well, good luck with this assignment. I'm trying to keep the assignments kind of down so they're not too long, because I know a lot of you are working on your own. And but I encourage you to let me know if you need help. So